Hey folks, so hey from Copenhagen. It's quite special video today because I start the new journey. So I will still work in a self-sovereign identity, but right now I will focus more on the future of the self-sovereign identity together with the personal assistant, artificial intelligence, and the way how we could make you smarter, more productive, and allow you to build your digital twin, allow you to build your uh, smart agents, and so on. So it will be the huge journey to the future. And today, actually, we will talk about quite interesting topic. We have our self-sovereign identity, and it's shifted the data ownership. So it's your data, you own it. You find the service that allow you to host your data. You have a framework that actually solve this problem for you. But what about the derivatives of your data? What about the compute? So when you need to use something that will use your data, how to make this process secured? For example, right now, everything that you send to the ChatGPT in some magical way, go to the model, train the model. You don't know what they do with the data. Maybe they sell it on some black market, dark internet, or whatever. Never knows. You don't know how it's used. You don't know how it's affect on the learning of the model. So it's a huge challenge. And then it's the super easy slogan that my team in Hyphen have, that don't trust it if you don't own it. So then is the question, how to run the compute, how to own the compute, and what to do if you could not just, build your own data center and run the huge model that require the tons of the GPUs and some heavy compute hardware and so on. So that's quite interesting topic, how we could build the computation that could be owned, and how we build a computation that could be secured. So yeah, right now we have a couple of interesting topics. For example, we have the machine learning combined with the homomorphic encryption, because with data it's super easy. If you want to store data outside but you want to have the huge amount of privacy, then you have the edge encrypt, that you encrypt all your data, you store it in an encrypted way. So somebody who wants to have access to your data then should steal some private key from you, and then it's the secure. About the computation, you could not use just the encryption because it doesn't have meaning. Unfortunately, we could not work with the encrypted data, but then we could have some kind of encryption systems that allow us to manipulate with the encrypted data. So one of these systems actually is the homomorphic encryption. Yeah. So, but the challenge of the homomorphic encryption for the machine learning and challenge of homomorphic encryption itself, that you have really limited amount of operations. So, for example, you could do the homomorphic addition in one schemas. You could have the homomorphic multiplication in another schemas. So even if you want to combine somehow the circuit that will have the multiplication together with addition, you even could convert between these two, and it's already challenging, it's already computation heavy. So the homomorphic encryption and the machine learning is on the early stage. I read a couple of papers, they are still quite interesting, but the precision of such models, it's around of the 70%, and actually the complexity of the problems that they could solve, it's not so high. So it's nothing to compare with the GPT or any kind of similar things. So yet another interesting domain is the zero knowledge proof machine learning, ZKML. It's yet another interesting stuff that worth to discover, but still computation heavy, quite complex, not production ready. So then what could be next? Then you should build the trust. You should build the trust with provider. You should trust the owner that do the computation. But then we get to the huge domain of confidential compute, confidential containers. Yet another area is the trust execution environments. Yeah, when practically everything nowadays hosted in containers, and how to get to know that the area of your memory and the CPU is not transparent to the host machine, so Amazon doesn't have the access to your data and so on. So the trusted execution environments give you the answer to this, but usually the challenge that trusted executed environments depends on the hardware, and it should be some special hardware, and it might mean that it's pricey, or it's quite specific, or it's limit your cloud providers. So that's quite a big topic, and especially for the machine learning, because for the machine learning you should have not just CPU, you should have the GPU too. So how to build a trusted execution environment with the hardware that have the protected GPU. So that's yet another thing. So this topic it's quite huge. I just in the beginning of the journey to this topic, so I want to hear something from you, what you think about it, what you're doing maybe in this space. So we should build the trusted protocol and trusted compute together. And as I said, that don't trust it if you don't own it. So let's move to the better, secured, and owner compute in the future. So see you soon in Berlin.